We've got a 6-mark question here on reversible reactions. So we've got a reaction here. A plus 2B makes C plus 4D. Everything's a gas and it's reversible. The forward reaction is endothermic, so let's write that on there. Endothermic. That's going to be important. Explain in terms of their effects on the rate of attainment of equilibrium and the equilibrium yield of C and D, whether the temperature chosen should be high or low. Well, to start with, rate. So we need to take everything in turn. Rate first. Rate. Temp should be high. Okay, there's nowhere near enough space here. You get far more room in the exam to answer this, so you need to answer in full sentences. I'm just going to put some abbreviations down. Temperature needs to be high. Why? Particles have more energy. If particles have more energy, collisions have more energy, and that makes it fast. Okay, so that's rate for temperature. Should we do rate for pressure as well? Let's do rate while we're on rate. So rate for pressure. So if pressure is high, then we have more particles. If we have more particles, we have more collisions. If we have more collisions, we have a faster rate. Next, catalyst. Catalysts speed up a reaction without being changed themselves by providing an alternate route that requires less activation energy. So that's dealt with rate. Now, a lot of people forget about rate with these questions. They think yield, and they go straight into yield and forget the rate. Well, half the marks probably are for rate. So don't forget rate. You need to do rate for everything. Temperature, pressure, and catalyst. An explanation for each of them. 2 now, yield. Okay, so temperature. Now we've got 3 rules for equilibrium yield and how to affect it. The first one's about temperature. Increasing the temperature favours the endothermic reaction. And we need to write that out. Increasing temperature favours the endothermic reaction. Okay, so let's go back to the reaction now and just check whether the forward reaction is endothermic or exothermic. Forward reaction is endothermic. Increasing the temperature favours the endothermic reaction. So increasing the temperature is going to favour the forward reaction. Therefore, increasing the temperature is going to increase the yield. That's what we need to say. Increased temp increases yield of C and D. So it's a no-brainer for temperature. It's an absolute no-brainer. High temperature, high rate, high temperature, high yield. And we could say that's just to conclude that would be wise. Pressure now. What's our rule for yield and pressure? Increasing the pressure favours the side of the reaction with fewer gas molecules. So we need to write that out now. Notice how you just need to write all these rules out. Learn them and write them out if we get questions like this. Increasing pressure favours the side with fewer molecules. Okay, so back to the equation. We need to count the molecules. There's no number before the A, so there's a 1 there. To count the molecules, we count the stoichiometry numbers. There's a 2 before the B, so we've got 1 plus 2. There's 3 molecules on the left-hand side. On the right-hand side, there's no number before the C, so there's a 1 there. 1 plus 4 is 5. There's 5 molecules on the C and D side. Increasing the pressure favours the side with fewer molecules. Now, there's fewer molecules this side, so if we increase the pressure, we're going to drive the equilibrium to the left, away from the C and D. So in this reaction, we need to say 3 molecules on left, 5 on the right. Okay, increasing the pressure moves, let's say increasing the pressure reduces the yield of C and D. Okay, so yield, it's not cut and dry whether it should be high or low. A high pressure makes a fast rate, but a high pressure, okay, reduces the yield. So ideally, pressure will be a compromise, a medium pressure. Okay, so it's quite quick and with a reasonable yield, so a medium pressure. 3, catalyst. Okay, catalysts speed up the rate of reaction. Catalysts speed up the reaction. Catalysts have no effect on yield. They speed up the forward reaction and they speed up the backward reaction, so they don't change the yield, but they do make it fast. So because they make it fast, we add a catalyst. Okay, a fairly standard 6-mark reversible reaction question. You have to get good at these, they come up so much. All these questions on aylsham-high-chemistry.com.